And we say that here we have two ways. We can use the U substitution and we can expand the logarithm if we can, or if it's possible. Now I want now to solve it with two ways, by the expansion and by the U substitution. And we have to see how can, or if we get the U substitution or the expansion, we will get the same answer. Let's see. Let's know now here in solve number 7. So in number 7, we say that y, it was ln x over 1 plus x squared. Let's use now the U substitution. Here, we assume that U is x over 1 plus x squared, and U prime will be 1 plus x squared, 1 plus x squared times 1 minus x times 2x. So U prime will be 1 plus x squared. Sorry?
To the power of 2 down.
Okay. Minus 2x squared over 1 plus x squared squared. So I get it as 1 minus x squared over 1 plus x squared squared. This is now U prime. Then after that, we say that the derivative is 1 over U times U prime, which is 1 minus x squared over 1 plus x squared squared. Then it is, let's now here write the reciprocal for 1 over U, which is 1 plus x squared over x times 1 minus x squared over 1 plus x squared squared. Let's simplify it. So we get the answer now as 1 minus x squared over x times 1 plus x squared squared. This is now, if we solve it now by the U substitution. Now let's see now how, if we solve it by the expansion, how can we get the same answer? Expand, then find the derivative. Let's see here now. Expanded, that means you have to write it as ln x minus ln 1 plus x squared. Then, so y prime will be, what is the derivative of ln x? 1 over x. And the derivative of 1 plus x squared, it is 1. You have to assume that this is U. So it is 1 over U, yani 1 over 1 plus x squared times U prime. What is the derivative of 1 plus x squared?
2x.
2x. So I get the answer as 1 over x minus 2x over 1 plus x squared. Now, let's write them, have the same common denominator. By multiplying here with 1 plus x squared by 1 plus x squared, here by x by x. So what did we get up here? We get 1 plus x squared minus 2x squared over x times 1 plus x squared. Then let's simplify it. 1 minus x squared over x times 1 plus x squared. Let's now compare if we get the same answer or not. Here if you find it by the expansion way, and here if you use the U substitution. On Wednesday, just I forgot to find the common denominator. So you can choose the U substitution if it's easier one, or if we have it as 1 plus x squared. If you have it as ln of 1 plus x squared, you must use the U substitution because you cannot expand it. But if you see that you can expand it, I think it will be very easier for you to find its derivative. Is it clear?
Yes, teacher.
Yes, teacher.
Yes.
Okay. Now, look at this type of questions here. Here, you have ln of x minus 1 cubic times x squared plus 1 to the power 4. Now, imagine now you have to use the U substitution. How do you find it? Is it easier for you to find its derivative? Think about it. Here you have to see, or to say that this is f and this is g. F times g prime. To find g prime, you have to find the chain rule. And you have to say x minus 1 cubic times g prime, which is 4 times x squared plus 1 cubic times 2x, the chain rule. You have to find the derivative of outside times the derivative of inside, plus x squared plus 1 to the power 4 times 3 times x minus 1 cubic. This will be now u prime. And this answer, you have to multiply it by 1 over u. This is now if you have to use the U substitution. Now let's use it by using the expansion way. Expansion way, you have to say it is ln of x minus 1 cubic times x squared plus 1 to the power 4. Are they added or multiplied?
Multiplied.
Multiplied. Since they are multiplied, I can expand it. So I have to say it is ln x minus 1 cubic. And instead of writing multiplying, you have to write plus ln of x squared plus 1 to the power 4. To convert the multiply into summation. Then the power here, you can write it as a constant multiple. So it will be like 3 ln of x minus 1 plus 4 of ln of x squared plus 1. Then after I rewrite it, after you convert it from a complicated logarithm function to be as a very simple one, you can now find its derivative. You have to say 3 ln of x minus 1, you have to say it is 1 over u, or 1 over x minus 1, times the derivative of x minus 1, which is 1. Plus 4 of 1 over x squared plus 1 times the derivative of x squared plus 1, which is 2x. I finished. Expand it, then find the derivative. So the dy over dx will be 3 over x minus 1 plus 8x over x squared plus 1. Do you have any question? Is it clear?
Yes, teacher.
Now, let's solve number 28. ln of cosine squared of x times square root of 1 plus x to the power 4. Now here, you have to say it is ln of cosine squared plus ln of square root of 1 plus x to the power 4. Then this 2 here before this one, wait a minute please. See, I will come back to this one, but I want you to find the difference between these two things. If I asked you now to find ln of cosine squared of x and ln of cosine x squared, look now, how can we deal with these two cases? In case number 2, here you have ln of cosine and all of it is squared. So what that means, you can write it as 2 ln cosine x, then 1 over cosine x times the derivative of cosine, which is negative sine. So it is negative 2 sine x over cosine x. So we can say it's negative 2 tan x. But in the second one here, you have cosine squared of x. To find its derivative, you have to say this is u. So 1 over cosine squared times the derivative of u. Here, what did you have? You have cosine squared of x. So it is 2 cosine x sine x using the chain rule. Then 2 cosine x sine x over cosine squared of x. Cosine cancel cosine, so you have it as 2 sine x over cosine x. So the answer will be 2 tan x. So if you have it then cosine squared of x, it's different than cosine x squared. Look at it for 1 minute and I will. So number 28, here we have d over dx for ln of cosine squared of x. We say the plus ln of square root of 1 plus x to the power 4. This one here, we say that it is like this is u. So 1 over cosine x squared times 2 cosine x sine x. The derivative of cosine is
negative sine.
sine, sorry. Plus half ln of 1 plus x to the power 4. Then we have it as negative 2 tan x, as we said, sine over cosine, plus half. Then here 1 over 1 plus x to the power 4 times 4 x cubic. Because I found 1 over u times u prime. So it comes like negative 2 tan x plus 4 x cubic over 2 times 1 plus x to the power 4. So it's negative 2 tan x plus, or equal, sorry, negative 2 tan x plus 2 x cubic over 1 plus x to the power 4.
Teacher, why not plus 4x cubic?
I simplify here. That's why.
Okay, teacher.
Is it clear?
Yes, teacher.
The others, miss.
Yes, teacher.
Yes, teacher.
Yes, teacher.
I think we have the same ideas, so I will not repeat it. Now let's start now with the integration involving ln of x. Now, did you remember that when I told you you want to find the derivative of x to the power n, I told you have to say it is x to the power n plus 1 over n plus 1 when n is not equal 1. And I told you you can find the integral of x squared or x3 to the power 3 or x to the power negative 1, but you cannot find the integration of, x to the power 1, but you cannot find the integration of x to the power negative 1. Why? Because if we put negative 1 here, you have to say negative 1 plus 1, which is 0, over negative 1 plus 1, 0. So it would be as 1 over 0, which is undefined. So I told you can use this formula where the derivative of x to the power n is x to the power n plus 1 over n plus 1 if n is not negative 1. Right. What is the integral, or what is the integration of x to the power negative 1? Or we can write it as 1 over x. Today now we are going to see what is the integration of 1 over x. The integration of 1 over x will be ln x plus c. So in the chapter 4, we learn how to find x squared with the integration of x, or x to the power negative 2, or x to the power negative 3. But x to the power negative, we can find the integration for x to the any power except negative 1. Today, we will see how to find the integration of x to the power negative 1. As you see here, 1 over x, the integration of it is ln of x plus c. We say that the derivative in the beginning of this lesson, we say that the derivative of ln is 1 over x. Now, the integration of 1 over x will be ln. And if you have a complicated one like 1 over u, you have to say it is ln of u plus c. Okay? The derivative of ln is 1 over x. And the integration of 1 over x will be ln. Let's have now more examples here. Now, find the integration of 1 over x from 1 to e. This is a definite integral. Now, I will see in my mind. The integration of 1 over x is ln of x. But this is a definite. So, from 1 to e. So, that's mean you have to find ln of e minus ln of 1. Now, as I told you, ln of e, they are canceling each other. So, it's like 1. And ln of 1 is 0. So, the answer is 1. So, the integration for 1 over x from 1 to e is 1. Now, let's find the integration of 1 over x from negative e to negative 1. The same steps. The integration of 1 over x is then x from negative e to negative 1. So now don't forget, here as you see we have absolute value. So I told you that it is the len of the absolute value. So when we substitute, be careful that you have to put the numbers between the absolute value. So it is ln of negative 1, not negative 1, it is ln, it's the ln of the absolute value of negative 1 minus ln of the absolute value of negative e. Now, ln, or before that, what is the absolute value of negative 1? It is 1. So ln of 1, it is 0, minus ln of e, I told you it is 1. So the answer will be negative 1. Because if you put ln of negative 1 in the calculator, it gives you math error. Don't forget, you have to put the answer in the between the absolute value, because here I told you the integration of 1 over x is ln of absolute value of x. Absolute value of x. So when you substitute, you have to put the numbers between the absolute value. Is it clear?
Yes, teacher.
Let's now have these examples here. Here, as we see, we have an expression, quadratic expression, a polynomial expression, sorry. 3x squared over x cubic plus 5. You have to find its integration. Now, we said before that we can find the integration of adding, of subtracting, of multiplied also using the U substitution. But what we have to do if they are divided? Like 3x squared divided by x cubic plus 5. In this case here, we have to use the U substitution. That's 3x squared over x cubic plus 5 dx. So we have to assume that the one or the side, the denominator or the term, we can say the term with the highest degree will be u. So we assume that x cubic plus 5 is u. So if x cubic plus 5 is u, so du over e dx will be 3x squared. Then rewrite it here. 3, so du will be 3x squared dx. So we assume that x cubic plus 5 is u. So du over dx will be 3x squared. By cross product, so du will be 3x squared dx. So that's mean 3x squared dx, instead of it, write du over x cubic plus 5 is u. So what did you have here? We have the integration of 1 over u du. What's the integration of 1 over u? What's the integration of 1 over u du?
U plus c.
Absolute value of u plus c.
Sorry?
Absolute value.
Absolute value of u plus c.
ln of u plus c. This is the integration of 1 over u. But now, instead of writing u, you have to write ln of x cubic plus 5 between the absolute value plus c. So here, if you have a polynomial expression and you want to find its integration, or in other words, if you have an expression divided by another expression and you need to find its integration, you have to use the U substitution, as you see here, then substitute it with U, then we all of us know that the integration of 1 over U is ln of U. Then substitute with U as x cubic plus 5 to find it as ln of x cubic plus 5 plus c. Is it clear?
Yes, teacher. Teacher, so we cannot make expand.
No, here there's no ln. If you have
Okay, teacher.
ln of 3x squared over x cubic plus 5, if you have ln, you have to expand it. But if there's no ln, you cannot.
Okay, teacher, thank you.
Is it clear? Grade 11, is it clear?
Yes, teacher.
So if you have ln, you can expand it. And let's see, as Hannah say, if you have it as before that, Hannah, let's make it before. So here, as you see, if you have it as 3x squared over x cubic plus 5, you have to find the U substitution, then find its derivative, evaluate it, then write it back. Let's have another example here. If you have the integration of 3x to the power 4 over x to the power 4 plus 2 dx. Here we have a polynomial expression and you need to find its integration. As I told you, the first step, you have to see where's the degree, where's the term with the highest degree. Is it a 3x to the power, let's make it here. So where's the term with the highest degree? Is it x to the power 4 or 4x cubic?
X to the power 4.
Exactly. So you have to assume that U is x to the power 4 plus 2. Then, after you find, or we assume that this is U, you have to find its derivative. So du over dx. Now, what is the derivative of x to the power 4?
4x cubic.
4x cubic plus 0. Because the derivative of constant is 0. So, du over dx will be 4x cubic. So, du will be 4x cubic dx. Then after that, 4x cubic dx, this one, can I rewrite it as du?
Yes, teacher.
Yes. And x to the power 4 plus 2, I rewrite it as u. Then the integration of du over u, I can rewrite it as the integration of 1 over u du. Now, what's the integration of 1 over u du? Yes, grade 11. What is the integration of 1 over u du?
Absolute value of u plus c.
Ln, no, don't. It is ln. It is ln of u plus c. Then let's now substitute with u as x to the power 4 plus 2. So it is ln of 4x cubic. No, sorry, I assume that this is u. So x to the power 4 plus 2 plus c. So the integration for 4x cubic over x to the power 4 plus 2 will be ln of the absolute value of x to the power 4 plus 2 plus c. Is it clear?
Yes, teacher.
Yes, teacher.
What did you notice from here? What's the relation between the denominator and the numerator? Yes, grade 11. What's the relation between the numerator and the denominator?
The derivation of the numerator. is
Derivation
equal
of
to
x
the-
plus
Sorry, Dareen.
x to the power
Wait,
4.
one by one. Yes, Dareen.
The derivation of the numerator is equal to the denominator.
Exactly. Thank you. So as you see here, the derivation of the denominator, okay, is the numerator. So if you see this case, if you see that the derivation of the denominator is the numerator, so you have to say that it is ln of the denominator plus c. I will repeat. If you see that the derivative of the denominator is a numerator, so the integration will be ln, the absolute value of the denominator plus c. Is it clear?
Yes, teacher.
Okay, tomorrow, inshallah, we will have more examples. I will solve it with you. I will repeat these more examples of this integration. And also we have to go now to see, we know all of us what is the integration of cosine, of sine, of secant square, but we don't know what is the integration of tan. Tomorrow, see also, inshallah, we will see what is the integration of tan and cotan.
Okay, teacher.
Thank you so much.
Okay, teacher. Thank you. Have a nice day.
Thank you. Bye-bye.
Have a nice day, teacher.
Hello, teacher. We hope to see you soon. Like, I got